Orbital Gardens, this is Mission Control. We are confirming acquisition of your signal. You are live in 5, 4, 3, 2...
Hello and welcome to episode 28 of Gardeners of the Galaxy, the podcast for all of the sentient beings in the universe who have a passion for plants. I'm Emma the Space Gardener and I will be your host as we explore gardening on Earth and beyond. News reports state that China's new Tiangong space station is preparing to host 1,000 scientific experiments on a wide range of topics. So in this episode I'm going to be exploring some of China's space plants history and why China's consumers are looking forward to eating rice from heaven. Before we get to that, I'm answering another listener question in my FAQ section. Ada Grabowska-Zhang has asked a question on behalf of her 7-year-old child, which is, what was the first plant grown in space? Now that's a brilliant question, which is surprisingly tricky to answer. If you Google that question, you'll get the response that the first plant to flower in space was our old friend Arabidopsis thaliana, the humble weed that botanists use as a model organism. In 1982, Arabidopsis flowered and set seed on the Soviet Salyut 7 space station. Some of the flowers were even presented as a tiny bouquet to the second female cosmonaut, Svetlana Savitskaya. She drew some lovely sketches of the plants in her logbook. Unfortunately, once the seed returned to Earth, researchers found that most of them weren't viable. Arabidopsis may have been the first plant successfully grown in space, but that success came on the back of some earlier attempts. The early space missions focused on getting to the moon and learning about the effects of radiation and the space environment on living organisms. They didn't have the time, the space, or the inclination for plant experiments. America's plant experiments really started with the Space Shuttle, which launched for the first time in 1981. However, the Soviets got started earlier than that, in their series of early space stations. I think the first plant was grown in space in 1971. Cosmonauts Viktor Patsayev and Vladislav Volkov sprouted flax seeds in the Oasis greenhouse aboard Salyut 1. They tended the fragile seedlings like parents. Patsayev referred to them as pets. Volkov was even more emotional, saying, "They are our love." Those plants didn't thrive, but scientists could only speculate why, as the samples died, sadly along with the crew, as their capsule depressurised on re-entry. And if you want to know what the first plant grown and eaten in space was, then that's even murkier. That honour seems to go to cosmonauts Vladimir Kovalenok and Alexander Ivanchenkov. They worked on an onion experiment on the Salyut 4 space station in 1978. According to an article in Air and Space magazine, the cosmonauts felt they had more onion bulbs than they needed and pestered the Earthbound scientists to allow them to eat the spares. If that is the true version of the story, then it doesn't count. They simply ate plant material sent from Earth. However, I've seen other versions where they ate some of the green onion shoots without permission. Given the Soviet secrecy of the time, and the fact that anything published would be in Russian, it's hard to figure out what really happened. So, the answer to the simple question, what was the first plant grown in space, is perhaps anything but simple. Thanks for asking such a brilliant question, Ada. If you have a question about space plants, you can email it to earth@spacebotany.uk or find me on Twitter, Facebook or Instagram. I'm also trying out a new system for you to leave me voice messages, and you'll find that with the show notes at theunconventionalgardener.com. Now it's time to take a look at what's been happening on the International Space Station. On the 29th of July, the Russian Nauka module docked with the ISS. The new module is officially called the Multipurpose Laboratory Module, or MLM. The MLM is the largest module flown to the ISS and includes the European Robotic Arm. That's a mobile robotic arm for installing large-scale payloads, performing transport operations, replacing and maintaining service and science equipment on the station's exterior, and supporting EVAs. The MLM replaces the decommissioned Pirs module, which has returned to a watery grave in the Pacific Ocean. After the MLM docked with the ISS, its thrusters unexpectedly fired, a mishap that took the ISS out of alignment. Mission Control corrected the problem and the crew remained safe. However, the event did have some ongoing effects on ISS operations. NASA's Jacob Torres says that the disruption delayed scheduled work on the Space Chilies experiment. The mishap also disrupted the launch schedule, delaying Boeing's Starliner OFT-2 mission. However, as I'm recording this, that launch has been delayed again by a technical issue, and we're still waiting to hear a new launch date. The The ISS crew has been working on a fresh batch of experiments for the Plant Water Management series. These are PWM3 and 4. As we know, water behaves very differently in microgravity, which causes problems keeping plants watered and healthy. The PWM investigations demonstrate different passive ways to control water delivery, including surface tension and system geometry. These experiments aren't growing plants, they're using things like sponges as plant stunt doubles. And in place of nutrient-rich water, they use tropical fruit punch, making it easy to see what's going on. According to a tweet from NASA astronaut Megan MacArthur, it smelled like she was growing lollipops. Now, according to the space station logs, the crew performed 2 days of wedge test operations, followed by cylinder test operations, all with real-time feedback from the ground science team. And that's not very illuminating, so I'm hoping to get a little bit more information on that topic for you in the near future. And I wrote a blog about the PWM experiments that ran earlier this year, and I'll link to that in the show notes for you. I'm Emma the Space Gardener, and you're listening to Gardeners of the Galaxy. Now, if you'll just join me in the Space Shuttle bus, we'll take a short hop across to the Chinese Tiangong space station to learn a little about China's spaceplant experiments. In June 2014, NASA astronaut Steve Swanson harvested the first lettuce from the veggie growing system on board the International Space Station. It was returned to Earth for safety analysis, and it wasn't until August 2015 that the ISS crew were able to sample some of their crops. The images of Scott Kelly and his crewmates tucking into space lettuce were seen the world over. But the following year, a similar harvest took place on the Chinese Tiangong 2 space lab, with far less fanfare. China launched Tiangong 2 in September 2016 as a replacement for the Tiangong 1 space lab, which retired in March of that year. The Shenzhou 11 spaceship carried 2 astronauts to Tiangong 2 in October 2016 for a 30-day stay. As always, preparations for the experiment began on Earth. Wang Longji, an associate researcher at the Astronaut Center of China, said the main reason for choosing lettuce was its 30-day growth cycle. As lettuce seeds are small, smaller than sesame seeds, the astronaut said, they were processed into small balls to make them easier to handle. Once they had been given a special coating, designed to separate from the seeds in contact with water, they formed balls the size of mung beans. Each seed ball was placed into an individual unit cell. The results later showed that the seed coating affected the sprouting process slightly. The astronauts started the plant-growing experiment on their second day on board. This involved setting up a culture system composed of small plastic units, a little bit like constructing a Lego kit. After watering the units and planting lettuce seeds, they covered the surface with plastic wrap. Mission Commander Jing Haipeng said that the seeds had germinated by the 5th morning. He and Chen Dong were happy and took a lot of photos and informed ground staff. After the seeds sprouted, they removed the protective film and turned on the lights. The unit had red, blue and green bulbs, with red as the strongest colour. The growth medium was a specially developed mineral material. The crew spent at least 10 minutes every day tending to the lettuces. They used a device to test whether the plants needed watering and injected air onto the roots of the lettuces to help them grow better. 6 days after planting, the astronauts thinned the seedlings. At that point, they thought the lettuces looked very fresh and greener than those grown on Earth. They used tweezers to pull out weaker-looking sprouts and left 2 in each unit cell. 3 days later, a second round of thinning left 1 seedling in each cell. At harvest time, the astronauts took leaf cuttings and root samples from the plants and froze them for return to Earth. Of course, these lettuces were grown as an experimental crop and not to be eaten. But that's how Jing Haipeng and Chen Dong became the first Chinese astronauts to grow an edible crop in space. China is currently working on its 3rd space station, simply called Tiangong. Its core module is called Tianhe, meaning Harmony of Heavens. Tianhe is about the size of a bus and launched in April 2021. Unlike its 2 predecessors, Tiangong is intended to be a long-term space station. Shenzhou 12 is the first crewed mission to the new space station, and 3 astronauts are expected to be on board for 3 months. I've got a couple of blogs that tell you more about Tiangong, and I'll link to those in the show notes for you. Shenzhou 12 carried nearly 30 grams of Nanjing orchid seeds into space for a 3-month stay on the space station. The orchids are from a popular variety called Hongkao, which has red buds and seedlings. This variety was selected and bred by the Provincial Testing Centre for Forestry Science and Technology, which is affiliated with the Fujian Bureau of Forestry. Since 2016, the centre has been working with the Flower Research Institute of the Academy of Agricultural Sciences of Yunnan Province, conducting research on breeding Nanjing orchids in space. In an earlier experiment, about 100 grams of seeds went to Tiangong 2 on the Shenzhou 11 mission, resulting in 2 sterile germinated strains. China's researchers carry out a lot of space breeding experiments to generate new plant varieties. The theory behind space breeding is that the unique conditions of space, including cosmic radiation, vacuum, and microgravity, can change the seed's chromosome structure. China has used space breeding to develop new varieties of agricultural crops and hopes to create orchids that bloom for longer and are more attractive and fragrant. China's space breeding program began in the 1980s, with seeds orbiting the Earth on a satellite for 5 days. China continued to use what I will call seed satellites through the 1990s, and the pace of its space breeding program is accelerating. In 2011, Professor Liu Luxiang, director of the Space Breeding Research Center at the Chinese Academy of Agricultural Sciences, stated that 100 new varieties have been produced by space breeding. The first of those was a strain of rice known as Huahang 1, for which China reported yield increases of more than 4%. Tiangong 6 is a new variety of wheat with higher protein levels and is great for baking. A 2011 paper in Space Policy also referred to a new kind of soybean with 11% higher yields, supersized green peppers weighing in at 500 grams, and giant cucumbers and tomatoes with an unusually high sugar content. According to Wikipedia, China's space breeding program is very successful. However, it requires a large budget and technological support that many other countries are unwilling or unable to provide. But it's worth noting that outside of China, scientists are less convinced that it works. Dr. Kerry Mitchell, Professor of Horticulture and Plant Physiology at Purdue University, has said, "Dehydrated seeds are very inert. I'm very sceptical that they'd respond to radiation in any way." And as we heard in episode 26, NASA sent 12 million tomato seeds into space for several years and then got schoolchildren to grow them. The results suggested that there was no improvement in yield from seeds that had been in orbit. And if space breeding really works, then it's not entirely clear why. Whether it's simply that seeds are being exposed to higher radiation levels or whether microgravity also plays a role. Professor Liu Luxiang suggested that Chinese space breeding program costs at least $500 for each seed launched into space, and that more than 90% of seeds remain unaffected by the experience. Whether or not the rest of the world agrees, it seems that China feels that's money well spent. An article in China Daily in November 2020 has some lovely stories about plant varieties produced through the Chinese space breeding program. It talks about tomato vines that can sprawl across 150 square metres of land and bear 10,000 fruits, and giant black-eyed pea sprouts measuring nearly a metre long. It says that space-bred crops are planted throughout China and are crucial to improving food security and yields and combating rural poverty. The article goes on to say that in 2018, China's space breeding industry had a direct economic impact of more than 200 billion yuan, nearly $30 billion, and produced over 1.3 million tonnes of food. That was from 2.4 million hectares, an area roughly the size of New Hampshire. China has approved more than 200 space-bred varieties, including rice, wheat, maize, soybeans, cotton and tomatoes, with 3,000 more in development. Chengcheng County in Shaanxi Province is home to a variety of what we would call Szechuan pepper, called the Big Red Robe peppercorn. According to the Kunming Institute of Botany, it has been used since the Han Dynasty for cooking, medicine, rituals, and even palace decorations. However, it's a low-yielding plant with sharp thorns that make harvesting difficult. And in fact, I have a young Szechuan pepper in my garden, and we refer to it as Mr. Spiny. It has a habit of pricking your bottom when you bend over to pick the asparagus. Anyway, back to ancient China. The Big Red Robe peppercorn was a tribute spice, enjoyed only by the privileged, the best known being Empress Dao of the Han Dynasty. She decorated her chamber with the condiment to signify fertility and prestige. These days, a farm worker can pick about 7.5 kilograms of this peppercorn per day, but after it dries in the sun, that's less than 2 kilograms of spice, so it's not a cost-effective crop. Guo Rui is director of the Shaanxi Province Engineering Research Center for Plant Science Breeding. In 2016, he and his team sent some peppercorns into orbit for 12 days aboard the Shijian-10 seed satellite. They were hoping to create a new variety with better wind and disease resistance. Instead, what they got was unexpected: a thornless variety. Sending seeds into space is the start of a longer breeding process. Once they return to Earth, researchers grow the crop over several generations to see whether it reliably produces desirable traits. They may also use earthbound breeding techniques to cross the space-bred varieties with others. Guo and his team hope to improve on the thornless peppercorn to develop a cultivar with a much higher yield that can be machine harvested. They're also looking at other crops such as peonies, goji berries and sea buckthorn. When China's Chang'e 5 spacecraft launched on a mission to retrieve a sample from the Moon in November 2020, it took with it around 1,500 rice seeds weighing 40 grams. During their 23 days in space, the seeds travelled through the Van Allen radiation belts and experienced violent sunspot activity. It was the first time that seeds had been sent on a deep space mission. On their return to Earth after their 760,000 kilometre journey, the rice seeds were sown in a greenhouse at the South China Agricultural University in Guangdong Province in February 2021. Guo Tao, Deputy Director of the National Engineering Research Centre of Plant-Space Breeding at the university, explained that these were second-generation space-bred rice seeds as their parents were also selected through space breeding. His team hopes that the rice seeds that flew on Chang'e 5 will surpass their parents and become better rice varieties. Webcams showed the growth of the seeds, which, as you can imagine, was about as interesting as watching paint dry. 2,000 seedlings were then planted out into fields in late May or June. That led to the first harvest of space rice in July. According to reports, the researchers bagged seeds that were a centimetre long into 3 large parcels. The team will select the best seeds and grow another generation in the hope of developing new varieties to boost China's grain harvests and its food security. China is also looking ahead to growing such crops in space. According to Wang Yanan, a space analyst and chief editor of Beijing-based Aerospace Knowledge magazine, China's researchers are hoping to conduct experiments to test a self-recycling ecosystem in space, which will greatly cut costs and reduce the resources needed for future crewed space flights. This will support more deep space explorations, including the building of a lunar research base and crewed missions to Mars. The space rice has generated a lot of interest in China, where people are wondering when they'll be able to cook rice from heaven for dinner. It's likely to take 3 or 4 years before any new varieties can be grown commercially. According to Zhu Li, a rice breeding expert based in one of China's major rice production fields, space rice will need to go through a few more generations and a series of tests, comparisons and regional trials before it passes provincial and state-level reviews. China is planning a Chang'e 7 mission to the lunar South Pole, currently expected to launch around 2024. Chang'e 7 will have a lander, rover, orbiter, relay satellite and a small hopping spacecraft to explore the rough terrain of lunar craters. It's an early step in China's plan to build a lunar base with Russia. Chang'e 7 will also carry a student experiment to the Moon. The China National Space Administration received 578 experiment proposals from students of all ages and has shortlisted 20 projects. These include silkworm cocoon hatching, moss rehydration, oxygen generation using plants in the low lunar gravity, and other biology experiments involving plants, insects, fungi and bacteria. A public vote will determine the winning project that will go to the Moon. And a similar contest has begun to choose a popular science experiment to launch with China's asteroid sample return mission. The plan for that mission is to visit the small asteroid Komoa-Aleva in 2024 and then travel to a main belt comet after delivering samples to Earth. As a fascinating aside, I have discovered that Komoa-Aleva was named as part of a project combining the traditional indigenous Hawaiian practice of naming astronomical objects with modern astronomical discoveries. This particular asteroid was first discovered at the High Altitude Observatory site on Maui in April 2016. It was officially given the name of Komoa-Aleva in April 2019. There's a lovely video about the project in Hawaiian with English subtitles, and I'll put a link to that in the show notes for you. At this point, I need to include my customary apology for all of the unfamiliar pronunciations I have mangled. If I could choose a superpower, it would be to speak every language in the world, but sadly that's not possible, so I just have to try my best. Continuing on the Chinese theme, a recent edition of my Meals on Mars newsletter looked at the evolution of Chinese space food from mooncake mouthfuls to microwave meals, so I'll link to that in the show notes for you. That's it for this episode. I've got a couple of great interviews in the pipeline for future shows, so keep an eye out for those. In the meantime, please share this episode with your friends so we can grow our Space Gardener community. Thanks to my patrons for supporting the show, and thanks to you all for listening. Goodbye.
Orbital Gardens, this is Mission Control, confirming termination of your signal. We've heard from Mark Watney and he'd love to visit for dinner in the Space Garden. However, he does have a concern about the menu. Apparently he's sick of potatoes. Mission Control out.